I'm Mike, and this is Sadia from New Space. And tonight we're hosting Dennis Silin from Exodus Orbitals.
Nice to meet you all, and pleased to be on the stage tonight.
Yeah, we're glad to have you, Dennis. So yeah, we're running a couple minutes behind. So if you want to, you can go ahead and kick off your presentation, and then afterwards, the way AirMeet works is we can break off into what are called tables. So everyone can kind of join and do some networking afterwards. So, yeah.
All right, I can present to the screen. All right. Share. Can you see my presentation slide,
Yeah.
Michael?
Yeah, we can see it. Looks good.
All right. So I will start and explain a little bit what we are building on Exodus Orbitals. And to summarize in just a few words, we're building Uber for satellites or Airbnb for satellites, a service where you can rent actual satellite in orbit around Earth for some amount of time, either one orbit, which is 90 minutes, or the entire satellite lifetime, which can be measured in years. So why would anyone need that? And the first, and most important, we all love watch other people explore space, and NASA missions or SpaceX Starship tests is an exciting show to watch. However, many of us want to try things hands-on, not satisfied with just watching other people do something. They want to do something themselves. However, getting into space industry, into any quality is difficult, and getting your hands to operate a spacecraft or becoming an astronaut is exponentially more difficult than just having a job in an aerospace company. Therefore, this is what we want to build: a bridge for the people to solve all the complexities of space industry, all the costs required to build and launch your own satellite, all the very numerous regulations that you need to comply if you're operating a real satellite in space. Satellite rental approach solves all of them. Here is our model in a little bit more detail. The satellite is in orbit, so what we give to the people, to our users and customers, is the ability to upload the mission software to control your satellite. In the same way it works with the web applications, mobile applications. We provide you the infrastructure, just like cloud computing providers give you a server to rent, or Apple gives you the entire App Store and the tools and their distribution model to sell your application. We will give you all the infrastructure that you will be able to use to build your own code that will run on the satellite onboard computer. And furthermore, we'll be able to access all the satellite instruments like imaging camera or software-defined radio, and will also give you the ability to control the satellite through the attitude control subsystem. Not maybe the full capability, but enough capability to point the imaging camera to the target of your interest and make a photo. So we'll have the service on the ground station, the satellite. The only thing you need is a laptop and an idea, and of course, some ability to call. I will talk more about the code part during the rest of the presentation to give you a better idea what can you do with renting satellite, with rental satellite, and effectively it is just another development platform. Why would anyone want to run their own code? That's simple. The amount of data that an imaging camera can generate is a lot. The modern, even the CubeSat ones, can do multiple gigabytes of data per minute, but the amount of data you can download on the Earth is measured in tens of megabytes, and that's a real number we got from the existing space companies. It's a bottleneck, and if you want to bypass that bottleneck, you will be it's very convenient to run your application on the onboard computer directly and get access to the 100% of the raw data, process it, extract all your business insights, and then just download that processed data on the ground, which can be only 1% of the total amount, but nevertheless will represent most of the value you can extract. Now, continue on the way and going back, what you get with the satellite rental, you get what are the most typical instruments you will be able to operate, and those are fairly, straightforward. For the first generation of our platform, it's going to be an imaging camera that you can use to make photos, either visible light or infrared, or even multispectral or hyperspectral, which are imager types for commonly used in Earth observation. Of course, with the better imagers, you get more data, but you will get access to all of the data on the satellite onboard computer, and it will be up to you what to do with it. Now, software-defined radio, I think, is already very useful, reprogrammable, reconfigurable instruments that have seen a lot of use on Earth and in space. Basically, it's the same as imager in terms of versatility, but for radio signals. You can read and listen to the variety of sources of radio signals on space and on Earth and on the ground. And in terms of commercial applications, two most common applications are getting data from maritime and aircraft traffic via the AIS and the ADS-B receivers. Again, raw data is plentiful, but you want some kind of organized reports if you want to plot any kind of traffic routes or extract some kind of insights from the amount of shipping traffic to a specific location. You can do that on the satellite directly. Here's a few examples of space apps. This is what you can get with renting just one orbit. You take a photo for a given altitude and just download the photo. Now, for the software developers, here comes the interesting part. The application may be trivial, but the implementation may be not so trivial. GPS works in space, but not necessarily 100% of the time. The image calibration or exposure may be totally off on the first try, and that's real life example. And again, the same photo can be done over the nighttime or the daytime, and with space observations can be done, for example, in early morning when the shadows are long and it shows the landscape better, or middle of the day when it just shows everything as flat as possible. Another second example of the basic space application SDR app that detects the ADS-B signals, for example, and that's something already implemented. In terms of there are satellites that do that as their primary missions. However, this can be also implemented as a software application and deployed on the different satellites. And if you are able to monetize that application, then you get the revenue from the data you're able to extract, or the data to reports you're able to create. Again, app concept is really basic, really simple, but the implementation have a number of tricky things that you need to be aware of. More advanced applications are possible, combining the data from multiple instruments and processing the data through the machine learning algorithms can be used. This is an example of a real-life advanced space application, I would say, or space application business case. Identify the ships on the picture, and then identify which ships are not transmitting the AIS signals, and match those data with AIS signals to see what's going on. And this is an example of Russian missile test that went haywire and the explosion happened. So there are some ships that are registered and there are some unknown ships, and this is an interesting opportunity for doing visual intelligence for everyone in the world on each other. And I don't want to go too much into that, but there are plenty of civilian and peaceful applications for this kind of space applications. And there are a lot more in the different industries, agriculture, maritime, or urban planning. There's already an existing and growing domain of those applications. What's lacking is the widely available platform to develop and run those applications, and this is what we are building. Now, a bit more on the technical side. Before any code is deployed to the satellite, it needs to be thoroughly tested and validated. So we will offer that capability as well. And illustrated below is how it should work. So starting from your development machine, you get the tools, you get the access to the test server. You build an app, it goes through our test pipeline. If it is accepted, it goes further to our mission control and ground station. And if it doesn't, you get the error log and results of the application tests. You will be able to fix any bugs, submit it again, and that until your app, the software package, is ready for uploading to the satellite.
Hey, Dennis, sorry to interrupt, but we're getting some feedback that there's a banner in the way of your screen or something. Oh, yeah, that one. Okay. There you go. Thank you.
Right. So I'll leave the slide for a second, for a few more seconds. And then after it's done, your code goes into space and runs on the satellite, and you will be able to plan when it will run and for how long. And again, it is a development platform, so you will be only built for the amount of time the application will run and not, the entire satellite cost. Now, all this concept I have been explaining so far has actually already been in development from, space agency, European Space Agency to be specific. The mission is called OPSAT, and I can leave the link to that mission in the chat later. And this operating more or less in exactly the same manner as I have described. And we are also one of the application developers, I would say, for this mission. So we're learning how things work from European Space Agency, and also building up our own experience in being the client of a service like this. So before anything happens, we need to understand and how things actually work in this manner. So I'm pleased to report that we are making good progress with the ESA, and all those bits and pieces have been coming to the coherent picture. Now, our own mission, which we plan to build and launch in this year, is already in progress. The launch date is tentatively scheduled for December 2021 on one of the CubeSat rideshare missions. This is will be our first satellite available to the customers globally, and we are currently offering already to pre-book the time on the satellite. If you're interested, get in touch with me. And here's our contact information. I am the technical co-founder, and I have a partner and my very close friend who is a business co-founder. We have both, the skills in the technology and business operations required to make this possible. And here's our website link, and you can have a look. It's simple to find, exodusorbitals.com. The longer story behind the name is quite interesting, and I might talk about that on another time. But if you look at the name, is basically Exodus. So people leave orbitals and leave the Earth and live in the space. This is our long-term vision, which one day may become possible. And if you have any questions, please ask them now or send me an email. I'll be very pleased to answer them. Again, this is the real deal. The satellite is being worked on. The operations, the business model has enough validation. We are currently doing the seed round fundraising and making some progress in that. And hopefully, next year I will be able to show you the real examples of space applications and people renting the satellites for their own needs. Thank you very much, and again, and again, thanks a lot to Michael for hosting our presentation.